So welcome back everybody. Today we'll be looking at another MAT question. This is 1D from the 2018 paper. And it's quite a simple question to state. So we've got this quadratic function. This is a very familiar object. We've got x squared minus 5x plus 7. And the question is to find the minimum of f of x minus 2. So this is a transformation of the original function. So there's two steps to this question. We need to know how to find the minimum of a function, the coordinates of that minimum, and we need to know what this transformation does. So firstly, let's just look at finding the minimum. There's a few ways we can do this. You might be familiar. We can take the derivative, set it equal to 0, and find the coordinates like that. Or another method, which is a bit more straightforward, is just to complete the square of this quadratic. So try and remember how to do that. This is going to be equal to, so we want to factorize this as x times a linear function plus a constant, right? Plus a constant. So the way we do this is we take the coordinate of the x term and we divide it by 2. So we have minus 5 over 2 in here. And we square this. So let's think about expanding this. We'd have x squared, which gives us the first term. We'd have x times minus 5 over 2. And we'd also have minus 5 over 2 times x, which would give us the minus 5x. And then lastly, just this constant, we just need to make sure it equals. So we're going to have the plus 7 from before. And then we need to subtract off this extra constant that we get here. So that would just be this squared. So we need to subtract minus 5 over 2 squared. So if you're not familiar with completing the square, just revise that. It's fairly straightforward. We can just simplify this quickly. So this is x minus 5 over 2 squared. And this is going to be over 4. So let's write this everything over 4. 7 is 28 over 4. And this is 5 over 2, so 25 over 4. And then we can just clearly see this is going to be x minus 5 over 2 squared plus 3 over 4. So now we have this function in the completed the square form. This is what this is. We can just read off what the coordinates of the minimum are going to be. And that's going to be the value of x where this bracket is equal to 0. Which we can clearly see is just 5 over 2. So that's the x coordinate. And then we need the value where this is minimized, which is just the constant, so 3 over 4. So this is the minimum. Let me just explain why this is true. If I do a quick sketch of this quadratic, maybe it'll look something like this. We want to find the coordinates of this point right here, this black dot. So we've got it in the completed the square form. So this is a positive a square term and a constant. So whatever value of x we put in here, when we square it, it's going to be non-negative. So if we want to find the minimum of this function, we can think about minimizing this bracket. So what value of x does this vanish? Does this go away? And that's exactly when this bracket is 0, so 5 over 2. And that's where this comes from. So we know that the x coordinate is 5 over 2. And then we just need to plug in 5 over 2 into this function to find the height. If we just do this in this form, it's very convenient. This vanishes, it's 0 as we said, and we just get 3 over 4. So that is how we find the minimum here. So the second step is just to translate this into this function. So if we let's call this something else to make it easier. If we call g of x f of x minus 2, this makes it a bit easier to deal with. We need to kind of revise what this transformation does. So an easy way, what I like to do to remember is if we just put a couple values in, see what happens. If we put x equals to 0, we have g of 0 equals f of minus 2, and let's also do 2. So g of 2 equals f of 0. So now let's just look at the graph, what this looked like. So f of 0, this would be the y-intercept up here. And now for this new function, it corresponds to g of 2. So it would be where on the x-axis, the value of 2, it would be the same height. So this could be a kind of a good way to remind yourself, this transformation is just a translation, it's a shift to the right by 2. So that's a good way to kind of, if you forget, it's a good way to remember what these transformations are. So our new function g of x is going to be exactly the same as before, but we just shift everything to the right by 2. And then it makes it a lot easier. We can just translate this answer to the minimum of g of x, or f of x minus 2. So we've just shifted everything to the right by 2, which means that the new minimum of g, the minimum is going to be this, our old answer, and the x-coordinate, we're going to add 2 to it. So 5 over 2 plus 2, which comes out as 9 over 2 in the x-coordinate, and the y-coordinate is exactly the same because we haven't changed anything there. This is a transformation that just affects the horizontal x-coordinates. And that's the answer, right? So that's quite a straightforward question. It's nice. It's just revising your school level knowledge. You just need to know how to find the minimum of a function and remember your transformations. So this is the answer to question 1D.